Hello friends, today I will discuss about the FYBSc practical chemistry. The aim of the practical is to determine strength of oxalic acid by titrating it with Kmno4. This is the second titration of this practical. The theory of this practical, oxalic acid has the formula H2C2O4 twice H2O. Oxalic acid does not undergo change in composition after exposure to air for a long time, so it is called a primary standard substance. And when there is the doubt about number of water molecules, water of the crystallization of oxalic acid, sodium oxalate is Na2C2O4 is used as a primary standard when a known weight of oxalic acid or sodium oxalate is dissolved in a known volume of solution. It gives a standard solution of oxalic acid or sodium oxalate. Oxalic acid is a dibasic acid, so its molecular weight is 126. When 126 gram of oxalic acid is dissolved in a 1 liters of solution, 1 molar solution is obtained. Similarly, when 134 gram of sodium oxalate is dissolved in 1 liter solution, the solution having 1 molar solution is obtained. Next is the reaction of this titration. 2 moles of Kmno4 plus thrice H2SO4, that is the sulfuric acid, to give K2SO4 plus twice MnSO4 plus 3 moles of water and 5 moles of oxygen. Next one is the chemicals of this practical. A sample of H2C2O4 solution given 100 ml volumetric flask, Kmno4 approximate 0.05 molar solution. That is the Kmno4, because it is the deep color of the Kmno4 itself, it as an indicator, hence is called as a Kmno4 having a self indicator. Solid sodium oxalate, and last chemical is 2 molar H2SO4 give the 10 to 12 ml solution for analysis. Okay, procedure of this practical. Part A, to prepare 0.5 molar sodium oxalate solution, have the sodium oxalate solution molecular weight having 134. 1000 ml 1 molar sodium oxalate solution contain 134 gram of Na2C2O4, and 100 ml 0.05 molar sodium oxalate solution contains the weight having 0.67 gram of Na2C2O4. And next procedure, weight accurately 0.67 gram AR grade of the sodium oxalate on a watch glass, transfer it in a clean 100 ml beaker and rinse the watch glass with distilled water, stir with the glass rod, dissolve the crystal, pour the solution into a clean 100 ml volumetric flask. And next point of this procedure, add carefully the little more distilled water that is necessary to make the volume up to the mark. Take out all solution in a clean beaker to make it a homogeneous solution. Next point is, it is the standard 0.05 molar Na2C2O4 sodium oxalate solution. Use this solution for standardization of the given Kmno4 solution. Part B of this practical. To standardize given Kmno4 solution, approximate weight is 0.05 molar. Fill the burette number first with approximate 0.05 molar Kmno4 solution. Fill burette number second having with standard 0.05 molar sodium oxalate. Take 9 ml sodium oxalate by burette number 2 in a 100 ml conical flask. Add to it half test tube about 10 ml of diluted H2SO4. This is the table reagent, that is the 2 molar. Next one procedure of this practical, heat the solution on a wire gauze about 16 to 70 degrees Celsius, add titrate this hot solution against Kmno4 solution, add a drop by drop addition, and from burette number first, continue the addition of Kmno4 till the solution in a conical flask becomes permanently faint pink. This is the end point of this titration. Call this burette reading in x1 ml. Add the same flask 1 ml solution of 0.05 molar sodium oxalate by burette number second. The pink color disappear. Next one is ensure the solution in the conical flask is hot. It is not hot. Heat it to about 60 degrees Celsius. Continue the titration by adding Kmno4 solution from burette number first. Permanent faint pink color appearance and the solution called the burette reading x2 same as the 1 ml addition and burette number third reading, and the end point of this titration is faint pink. This is the three burette readings x1, x2 and x3 molarity of Kmno4 same as part C. To determine the strength of H2C2O4, fill the burette first having Kmno4 and dilute solution of oxalic acid in 100 ml distilled water. Pour this solution in beaker and stir well, and fill the solution having oxalic acid in burette second. Take 9 ml diluted oxalic acid, that is the H2C2O4, and burette number second in a 100 ml conical flask. About the 10 ml 2 molar H2SO4 and heat the solution. Add Kmno4 solution from burette first and drop by drop addition and shaking the flask. Do not add Kmno4 solution too rapidly, otherwise the brown precipitate, that is the Kmno4 heavy diluted solution is used, and continue the addition of Kmno4 till the solution in the conical flask becomes permanently faint pink, and end of this titration the burette reading heavy Y1. Same repeated procedure having 1 ml addition of oxalic acid, and to titrate the Kmno4 the burette reading second Y2, and same first 1 ml addition of oxalic acid and burette number third. The end point of this titration is pink color disappear, and heat the solution and continue the titration. This is the three part of the titration. Next point is observation table. Part B having to standardize the Kmno4 solution. Given sodium oxalate solution, exact normality of Kmno4. First, find the exact molarity of Kmno4. The first burette and second burette having Kmno4 having first burette and sodium oxalate having burette second. Indicator is Kmno4 is the self indicator. Do not other indicator for use in this practical. End point of this practical colorless to faint pink. Next, the equation of this equation of this practical, and burette first means Kmno4, burette second having sodium oxalate. The Kmno4 having x1, x2, x3 reading to find out the sodium oxalate 9 ml, 10 ml and 11 ml, and this is the part B, and part C having to determine strength of H2C2O4 in given solution. The given value to standardize the Kmno4 solution to find the strength of H2C2O4 having the oxalic acid of given solution. Burette first to fill the Kmno4, burette second having oxalic acid, Kmno4 having the self indicator, end point colorless to pink, and equation of this titration, and burette first having Kmno4, burette second H2C2O4 9 ml H2C2 oxalic acid 9 ml, 10 ml, 11 ml to give the Y1, Y2, Y3 three readings. Next, with the calculation of this practical to standardize Kmno4 solution to find the exact molarity of Kmno4. Kmno4 is equal to 5 moles of Na2C2O4. M1V1 is equal to M into V. M1 into X1 is equal to 0.05 molar into volume having first 9. m2 putting the value same as m2 into x1 is x2 is equal to 0.05 into 10, and given value is x2 determine and third one having m3 into x3 is equal to 0.05 into 11. The molarity of Kmno4, that is the m4 is equal to m1 plus m2 plus m3 upon 3. This is the mean of the m4. This is the exact molarity of Kmno4. Same as part C, having the first is the Kmno4 and second is the oxalic acid, and same as the calculation for Kmno4 and Na2C2O4. The value having the MD, MA, and C upon 3. This is the 3 readings and the mean. And last point is the strength of H2C2O4 in gram per liter. This is the formula of this equation. Strength is equal to molarity into molecular weight. Strength means M into 158. This is the molecular weight of oxalic acid, and the calculation with a gram. And last point of this practical is the result table. 10 ml of sodium oxalate solution required. This is the x2 ml of Kmno4. Second is the exact molarity of Kmno4 solution is the m4, and third is the 10 ml diluted H2C2O4 solution required. This is the y2 reading ml of Kmno4. And fourth point of this result table, molarity of H2C2O4 solution having the oxalic acid, and this is the MD. And last point of this result table, strength of H2C2O4 solution having the A is equal to grams per liter. Thank you for watching the video.